In this session, we are going to learn and implement a queue. Queue is a linear data structure that is open at both ends. It's like a channel. It has a bunch of operations in the first in, first out order, meaning the element that gets first into the queue is the one that gets out of the queue first. So if we are required to add a new element, we go and append it to the end of the queue. That is generally referred to as rear end or tail of the queue. It's called enqueue operation. And if we are going to remove an element from the queue, it's going to be from the front of the queue, which is head of the queue, and it's called PQ operation. So basically, you can think of a railway ticketing system or airline boarding system where the person who gets first into the queue is the one who gets out of the queue. With this background, we'll go ahead and implement a simple queue in the first in, first out order. And we are going to build queue with help of slice. Slice in Golang is a fundamental data structure used to represent multiple dynamic size sequence of elements. Slices are similar to arrays but are more versatile because they can grow or shrink as needed. Basically, slices do not have fixed size, which means you can add or remove elements from them easily. So now with the help of slice, we will implement queue. We are interested in building QR, NQ operation, DQ operation, and a list operation, which will dump the elements of the queue to the spread. So to begin with, I'm going to create package main, import FMT for printing statements or logging messages. So now I'm going to declare or define queue. And as I said, I'm going to have a queue of clients. So it's going to be type my queue struct, and this is going to be client. So I'm going to say element of integer. Now we will perform three operations. Enqueue operations that going to push an element to the back of the queue or rear of the queue. So insert an element to the rear end of the queue. DQ operation to eject or remove the element from front of the queue. And then we are going to have list operation that's going to dump all the elements of the queue from front to rear. And finally, we're going to have a driver that's going to remove all of these operations one at a time so that we learn the working behavior of queue. Calling main for queue, or I can say building queue. Fine. So with this, we can start with NQ operation. NQ operation typically means that we are going to add an element to the back of the queue. So adding element to the back of the queue here is adding element to the slice. It's pretty simple. We can go ahead and create this star my q in q, we're going to insert x type in. And this dot element is going to be appended with x. As simple as that. If the element here is nil, basically empty, it's going to create the first element. Otherwise, it's simply going to add the parent. So adding an element to a slice is very, very simple. This is all that we need to do. Next, we will go ahead and remove the element from the queue, which is the dequeue operation. So we call this my queue, dequeue, and we can return the element that we have pulled out. We can also return the error. So we can return two value. Now, if the number of elements in the queue is zero, basically if queue is empty, there is nothing to return. So we simply return and say that queue is empty. If len of this dot element equal to zero, this is parity, and we check if queue is empty. This is for here. Okay, we simply return -1, comma fmt dot error queue is empty. Otherwise, we pull the element from the front end of the queue. Extract from the front of the queue the first element. So that is the queue operation. This dot element of 0, that's the first element, is something that we are going to pull out. We are going to return that element, comma nil, the error is nil. And now we update the queue after pulling out the first element. So that's going to be this dot element equal to this dot element, everything except the first element. So that's going to be 1. So this is the style of extracting the element from a slice. So element of 0 gives the first element or front of the queue, which we have pulled out and obtained in E. Now everything except the first element is something that's going to be available after PQ operation. So we are performing this dot element 1 colon, and that gives the remaining queue, and then we are going to yes. Now we are required to call each of these function in the driver. The list operation is something that we need to implement to dump all the elements from the queue. This my queue, list queue, we are going to print everything. So for E in range of this dot element, this is going to be element. We are going to print that. Now we'll invoke queue, queue equal to my queue, and then I'm going to call enqueue operations couple of times. Enqueue few elements, q dot enqueue, going to push one. Now I'm going to q dot enqueue, going to push two, three. Okay, so I have put four elements now. Now if I say q dot list queue, this will give me elements that have been pushed into the queue. So first I'm pushing one, and next I'm pushing two. That's going to be on the top. So we're going to add like this. And then I'm going to push three, and then I'm going to push four. So one is going to be in the front. So that was the first element that we pushed here. So I'm going to say two is going to hold one here. Q is going to hold one and then two here. Q is next going to hold one, two, and three. Finally, the state of the queue after pushing four elements will be now if we perform PQ operation, PQ of P dot PQ, this is going to give me a BQ value. That's going to be 12 comma here. So after this operation, the state of the element will be 2, 3, and 4. 3. We can confirm that by performing list operation after this. To make use of this trial and error, so if this is the case, then we'll, okay. Now if error is nil, then we will print the element that is reviewed. Fmt dot println dq colon percentage D value. Otherwise, you'll print the error. Fmt dot println and make this printf. Okay, and put a slash then the line separator. The typo here. Now it all looks okay. So yeah, we are done with the typical implementation of Q using slides. So syntactically it looks perfectly fine. Good to run. I'll open the terminal. Now we can change go run Q up. We're going to have the elements listed, then the DQ operation, and then again the elements listed after the DQ operation. Okay, okay. So this is now calling the main driver. Elements is this 1, 2, 3, 4, as we had expected here 1, 2, 3, and 4, and then the DQ operation is 1. That's correct. And after DQ we have 2, 3. So we are done with the implementation of Q and also been able to demonstrate that. For addition, before we close on this, we can verify the working behavior of queue after inclusion of an element into the queue. Basically, after every NQ, we can check the behavior. So that's going to be like this. Let me insert it after each NQ. Okay. So here we should get 1. Here we should get 1 and 2. And here we should get 1, 2, 3 and 1, 2, 3, 4. Instead of making elements printed over line, we'll change it such that for every list it prints the single line. I'm going to say dot dot percentage D dot dot comma E, and after every list just going to give a line separator. So this will look pretty neat as we print them. Want to save this? Okay, let me clear the screen. So we should have 4 entries here listed as you see, and then a DQ operation finally. Again, a listing after DQ operation. Let me run it. 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, DQ, and then the digit list. Perfect. So we have seen the working behavior of the queue with DQ and NQ operations. Got it. That's